Here's their example. A plus B makes AB. This is just generalized, right? I like real examples. I don't like A's and B's. I like when we put elements in there. But in general, anything that loses electrons is being oxidized. And it gains electrons is being reduced. That's the key. So you have to decide, hey, what's the charge on here? What's the charge doing? If it's gaining electrons, it's going to go from being positive or zero to being negative, right? When it gains electrons, that's negative charge. When it's losing electrons, it becomes more and more positive, right? So, here's a good example. Everybody knows what that is on the right-hand side?
Statue of Liberty.
Yeah, Statue of Liberty. What does Statue of Liberty look like when it was brand new? It was very pretty. It was like a shiny new penny. It was covered in copper. If you talk to some really old folks, they talk about saving pennies and stuff. Right? Huh? Yeah. Most people don't even know to pick them up anymore. New pennies are shiny, right?
Yeah.
Why is it not shiny anymore? Because it did what? It oxidized. Oxidized copper is green because the copper is combined with oxygen. What's the charge on copper right here? What's the charge on copper right here? 2 positive. How do you know that?
That was a guess, actually.
It is 2 positive. Anybody want to tell me why it's 2 positive? No.
Because of the oxygen?
Because of the oxygen. Oxygen's always 2 negative. So it's got to balance that. So copper's 2 plus. That's copper 2 oxide, right? What did it start at? Up here, when it started, is 0, right? So it went from being 0 to 2 plus. It did what? It lost electrons. Now, the way these 2 reactions are written right here, these are called half reactions. One's an oxidation, one's a reduction. Note that copper is losing electrons, oxygen is gaining electrons. Oxidation and reduction are always coupled together. You can't have one without the other. Okay? You should, if you haven't seen this, it must always be lab. Did y'all do the chemical reactions and balancing reactions? Have y'all done that one yet? You hadn't done that one yet?
No.
It's hard to figure out where everybody is because of all the snow and everything, right? It's messed up. One of my labs did it this week and the other one's going to do it next week. So I don't, it's all crazy. In that lab, you will actually do this. You'll have some copper sulfate. The blue solution is because it has copper 2 plus in it. If you put a piece of zinc in there, eventually that solution will be clear. Because the copper will go to be copper solid. So in this case, what's happening to the copper? It is being oxidized or reduced? It's being reduced. It is gaining electrons. So who does that mean is being oxidized? Somebody has to be oxidized. The zinc is going to be oxidized. The zinc 2 plus. And the solution will be clear because all the copper will leave. Okay? This one, they just put the strip in there, let it go for a little while, and they pull it out, and you can see the copper on the strip, right? So, each one of these is a half reaction. It's either an oxidation or a reduction. The first one, what's that element that we have? Anybody know what element that is?
10.
That's 10, right? So what's happening to it? 10 solid goes to be 10, 4 plus, and 4 electrons. What is it doing? Is it gaining or losing electrons? Losing electrons. It is being oxidized. Okay? What about the second one? Who says oxidize? Who says reduce? Who really doesn't know? Thank you for being honest. Look at the iron right here. What's it doing? Here it's 3 plus, right? It has to gain 1 negative charge to become 2 plus, right? So it's gaining an electron right here. And then it's left as 2 plus. This is reduction. Here iron is being reduced. All right, bonus question. Has anybody ever done this reaction? Is anybody
Rust.
currently doing this reaction right now?
Are we resting?
No.
Oh.
Rusting is iron 0.
Oh.
You don't know? Who's had anatomy? You've had anatomy physiology.
Wait, what's the?
Have you ever done this iron reaction right here? Where do you see this iron reaction in AMP? RBCs? Red blood cells? What's in the middle of a red blood cell? What molecules? What molecules in the middle of a red blood cell?
Oxygen.
Well, oxygen binds with something. What does it bind with? Hemoglobin?
Your blood.
Y'all don't learn about hemoglobin in
A couple of years ago.
I have to fuss at my AMP instructors. You didn't take, did you take AMP here?
No,
No.
but I took it like 2 years ago.
Do you have iron in your hemoglobin?
I hope so.
Yes. And why do you have iron? Because it easily can convert from 3 plus to 2 plus. Okay? Plants also have lots of iron because they use it in their chlorophyll. Okay? And it easily converts from 2 to 3 and helps them transfer energy. Okay? The last one, is that oxidation or reduction?
Production.
It's reduction again, just like B, right? It's gaining electrons. So reduction is gain of electrons, right? Anybody ever done that one? It's not in your blood.
Ugh.
What's that called on the left? What's the name of that chemical on the left? Chlorine. Where do you use chlorine? Huh?
Water.
In your pool? If you had a pool.
Yeah, I have a pump.
Drinking water.
Yeah, you probably don't want to put a whole lot in drinking water. It's not good for you.
No.
But there's a little bit. What is it doing? It's gaining electrons. Where does it get those electrons from when you put chlorine in your pool? What does it do? No. Why you just wasting it if it's going to react with the water?
It's cleaning it.
How's it cleaning it? Y'all don't think about this stuff? You just throw chlorine in there and hope it works.
I mean, I've never.
When it turns on, it's green.
It takes, yeah, it makes.
To do what?
It turns off full green.
I thought it was supposed to take the green away.
Well,
That's
it
because of
kills.
the iron in our water, because we
Yeah.
use our.
What's it supposed to do? It's supposed to kill the algae.
Bacteria, right.
And it decomposes the organic material that's in your pool, right? How does it do that? It does that by taking electrons from the algae and basically disrupting their cells, right? I want y'all to think about this stuff when you do it. You gotta always ask why. Anybody have any little kids or been around little kids and all they do is ask why?
Yes.
You think it's annoying as hell, don't you?
Yes.
Yes.
My son's 17, he still says
Stop
why.
asking why, so by the time we're in your class, we don't want to ask why.
It's one of the greatest traits that a person can do is ask, why does that work that way? That's how you learn. That's how you learn. That's what they're doing. They want to know.
Not everybody feels that way though. But a lot of people don't want you to ask them questions.
So then why don't you do that?
Why does it do that? Because the chlorine, the structure of chlorine is not very stable, and it would prefer to be chlorine ions as opposed to being chlorine gas.
So
And I
why do they
think
make
this
it
is-
look so complicated?
Do it.
So why do they have to make it look so complicated? Why can't they simplify or make it?
Because you just want it, so that it makes it easier for you just to agree with them and just buy everything that they tell you to buy.
So when there's algae on the pool, or, you know, where does it actually, it just disappears, evaporates?
Yeah, what happens is it decomposes the organic matter. It breaks the bonds in the organic matter, and the organic matter releases electrons and makes carbon dioxide. It oxidizes the carbon.
And it goes into the air we breathe.
Yeah, basically.